Hello everyone, my name is Ashish Swarnkar from Electronics and Instrumentation Engineering, Institute of Engineering and Technology, Bundelkhand University, Jhansi. Today I am going to take a lecture on Hamming codes. So students, what's Hamming code? Let me tell you about some codes. So, uh, Hamming code is a class of linear block codes which are used to detect or correct errors in data transmission or data storage in computers or computer networks. So, let us see how you get a data and how you encrypt the data, make a Hamming code, and when we transmit the data or code. So, at the receiver end we can check whether our data is encrypted, whether our data is corrupted or not by using the Hamming codes. We also check and detect the error. Okay. So, let us take an example. Here, when we make a code, that is Hamming code, from the given data, we must know about something, that if you are given a data of 4 bits, data of 4 bits, then your code will be of 7 bit. Okay. Means here we have taken an example where data is of 4 bits. So, our code will be of 7 bits. If data increases, then code size also increases. So, I have written a dummy code which is of 7 bit long. Out of this 7 bit, look the number. Look these numbers which I have underlined. Actually, these numbers are in the 2 raised to the power n. Remaining numbers are not comes to these category. So, these places are special and we use these places for parity bits. Let us name data and parity bits as parity bits are P1, P2, P4, while our data bits are D, 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 D. Look how I named the blocks. The number which comes in the 2 raised to the power n category are reserved for parity bits and remaining boxes are for data. So, first we have to fill the data which is given in our problem. Okay. Data is 1 0 1 1. Now, our objective is to make a 7-bit code. Out of these 7 bit, 4 bits are given. Now, we have to find the 3 bits, remaining 3 bits. These 3 bits, the process of calculation of these 3 bits are I am going to tell. So, first step is for calculating P1. For calculating P1, let us stand on bit 1. Let us stand on bit 1 and check 1, skip 1. I repeat, stand at 1, P1, check 1, skip 1, check 1, skip 1, check 1, skip 1, and so on. Here we get a code which is 1 3 5 7. So, for calculation of P1, we take a group 1 3 5 7. Okay. Out of this group, we have to find the bit at position 1 using the bits of 3 5 7. Here we have to check that the parity in this group must remain even. So, the number of ones at these position must be even. This is obtained by XORing the other 2 bits, look, here we take the data from bit 3, bit 5, bit 7, XOR them all and put the result into the bit 1 location. So, P1 can be obtained as P1 is equal to D3 XOR D5 XOR D7. It means three, 5, 7, that is 1, 1, 1, 1 XOR 1 XOR 1 XOR 1. Result is result is 1. The basic logic behind the XORing function is that an XOR function is odd function. It means you have to count the number of ones. If the number of ones are in odd number, so answer is 1. If the number of ones are in even number, so answer is 0. Here we have 3 ones, 1 2 3, because 3 is odd number, that is why answer is 1. Similarly, as we calculated P1, this is P1. Similarly, we can calculate P2 and P3 like this. Step 2, for P2, what will be the group? This is the procedure for P1. For P2, let me erase this. For P2, we just stand at position 2, that is here. Now, stand at 2. Now, take 2, skip 2. We will take 2 boxes, skip 2 boxes. Take 2 and skip 2. Here we get the second group. Second group is 2, 3, 5, 2, 3, 6, 7. 2, 3, 6, 7. Which is parity? This one is parity. This one is parity. And parity bit is obtained by XORing the remaining 3 bits. So, that means P2 is equal to XOR of 3, 6, 7. That means D6 XOR D3 XOR D7. What are the values at this position? 3, 6, 7, 1, 0, 7. 1 XOR 0 XOR 7. So, the bits at the position of 1, 3, 7 are 3, 6, 7 are 1, 0, 1, 1, 0, 1. So, as I told you that the output of XOR function is 1 if the number of ones at its input are odd. Here we get number of ones are 2, 1, 2. We have 2 ones, that means answer would be 0, and this is the value of P2. Now, in similar fashion, I can write P3. For P3, again we draw a pattern. Now, sorry. Now, next parity is P4. Next parity is P4. Look, P1 is calculated, P1 is calculated, P2 is calculated, P1, P2. Next is P4. P4 can be obtained by making another group. For P4, let us stand at position 4 and check 4. 1, 2, 3, 4. Check 4, skip 4. By checking 4, we found a group, that is 4, 5, 6, 7. 4, 5, 6, 7. In this group, this is the parity, and this parity bit is obtained by the remaining 3 bits, which are P4 equals to D5 XOR D6 XOR D7. What are the data at this position? 5, 6, 7. Data is 1, 0, 1. Data is 1, 0, 1. Result would be 0. This result we take into the box. Now, the code is generated by filling these parity bits into the boxes. P1 is 1, P1 is 1, P2 is 0 and P4 is again 0. This is our required Hamming code. Now, let us check whether if we send this data at the receiver, then is it possible to find the error and correct the error. So, for this purpose we take this example and we insert an error, and we will see that whether it can check or detect an error. So, our example would be 101 0101. At transmitter end, our data would be 101 0101 101 0101. So, here is a transmitter and this is receiver. Between this transmitter and receiver, there is a channel which is noisy and which can add error in any bits. So, any of this bit can be corrupted, and corruption of bit means the bit can be altered. Let us check. Let us take an example that at the receiver end the answer would be 1 0 1 1 1 0 1. If you compare both these datas, you can see that this bit has occurred an error. Actually, I know because I inserted the error. Now, we are going to see how the receiver end can detect and correct this error. So, as we have written the address of these cells, we write the addresses like 1 3 1 2 3 4 5 6 7. Okay. The receiver end also knows the same procedure as the transmitter. So, here we also take the similar group which we were taken in the transmitter. See, these are the groups of the transmitter. For P1, group is 1 3 5 7, second is 2 3 6 7, third is 4 5 6 7. So, at the receiver end, it also XORs at receiver. We get check bits. Check bits are C1, so the check bits we calculate are as follows. First, we take these group. First group was 1 3 5 7. Let us XOR these bits. 1 3 5 7 means 1 1 1 1. It gives 1 XOR 1 XOR 1 XOR 1. Result is 0. Why 0? remember these lines and answer as I write. Second is, our second group was 2, 3, 2, 3, 6, 7, 2, 3, 6, 7. If we XOR these bits, we get 0, 1, 0, 1. 0 XOR 1, XOR 0, XOR 1, 0, 1, 0, 1. Answer would be 0. All right. Now, in the third group, our third group was 4, 5, 6, 7, 4, 5, 6, 7. So, we XOR these bits, we get data 1, 1, 0, 1, 1 XOR 1, XOR 0, XOR 1, 1, 1, 0, 1. Now, the number of ones are in odd, so answer would be 1. So, this is known as, these bits are C0, C1, C2. We write these bits as C0, C1, C2 is equal to 1, 0, 0. This is binary. Here we can see that this system has found the error, has found the bit or location which where error is occurred. So, here we calculated C1, C2, C3, 100, 100 is a binary whose decimal is 4. So, bit 4 is at error. We can see this is position 1, 2, 3, 4. So, receiver has found the bit 4 is in error. So, what receiver will do? Receiver detected error. Receiver has detected error. Now, how it will be corrected? This error will be corrected by altering the bit. So, the bit which has been under error is inverted. Now, the correct code is would be code would be 101, 101. This bit would be inverted 0, 101, 101. So, we can see we got the exact format which was transmitted from the transmitter. Here we have completed the topic Hamming code. Thank you very much.